Hello students, in this video we will discuss about the benzyl carbocations stability. And if different groups are attached to that benzyl carbocation, so how the carbocation stability increases based on that groups. Okay, so in that first one example is benzyl carbocation simple compound. Next second one, here one OCH3 group attached to the benzyl. Next in meta position, one OCH3 group is present. In fourth compound, or the position, one OCH3 group is present. So these are the compounds. In these four compounds, which one is the most stable? So what is the order? The stability order of the given benzyl carbocations. So how to identify in this? So in the before video we discussed if any group which is attached to the ortho and para positions, so that time it acts as a mesomeric conditions. If one electron releasing lone pair of electron present on the given compound OCH3, so this group now it acts as a plus M group. If a plus M group is present after that, minus I also present. Now coming to this OCH3, this one is the para position. Now first which effect is influenced? Plus M effect. After that minus I also present. Now this position is para position. This position is ortho position. Okay, one is para, another one is ortho. Now coming to this case, this position is meta. If any group is present at meta position, so there is no resonance or there is no mesomeric effect. Now here this group alone, it acts as a only minus I group. So these are the conditions. So which group increases the carbocation stability? The releasing group only always increases the stability of the carbocation. So plus M group is nothing but electron releasing group. Here also this one is electron releasing group. Electron releasing. This one also electron releasing. First case. Now these two most stable carbocations. And coming to the A and C. These two most stable and mesomeric effect means resonance is equally present. So in these two, which one is more stable, we will discuss later. Then next coming to the compound A and C. In these two compound A and C, the OCH3 group is present at meta position. So this one is a minus I. So electron withdrawing group. This group acts as electron withdrawing group only. That means the carbocation density decreases. Okay. So carbocation density here decreases. So density decreases means this one least stable carbocation. So this compound is least stable carbocation. So compared to A and C, C is the least. After that, A is more stable. Now coming to the B and D. In these two, the mesomeric effect is commonly present. Next to go through the minus I effect. In these two cases, minus I effect, OCH3 are the adjacent 1, 2 position, here 1, 4 position. So which one is very near the minus I group? The minus I group next decreases the stability. Here also minus I is decreases the stability of the carbocation, benzyl carbocation. But here it is very far compared to D compound. So here the stable compound is B. B is the most stable compound. B is more stable than D. D is more stable than A. A is stable than the C. Now this one is the stability of the benzyl carbocations. So this is the one kind of method to identify the carbocations. So next, second example. Second example. So benzyl carbocation. Meta position, one NO2 group is present. Ortho position, one NO2 group is present. Para position, one NO2 group is present. So in these four given compounds, the stable carbocation, how to identify? Now, the first case, there is no group, either releasing or withdrawing group is present. Now it is commonly it is a constant only. The next, coming to the second compound, one NO2 group is attached to the meta position. This position is meta. Why this is meta? With respect to carbocation. With respect to carbocation, 1, 2, 3. The third position is the meta position. Now the adjacent position, this position is ortho position. Now the last compound, this position is the para position. Now this is ortho, this position is para position. Okay, these are the positions. Now, if any group present at meta position with respect to carbocation, always inductive effect only present. Now, this NO2 group acts as a minus I. Now, coming to the NO2 group at ortho and para position, mesomeric effect only present. So, NO2 group generally belongs to which one? Minus M. Here also this one belongs to minus M group only. So, after that minus M, NO2 group acts as a minus I also. So minus M groups means electron withdrawing groups. The minus M resonance is common in these two cases. Now C and D compounds always the least stable carbocations. Least, very least. Why? Because minus M means effectively withdraws electrons with the resonance or the mesomeric effect. Now compared to that, A and B conditions, here minus I group is present at meta, this one also withdraws electrons. So based on these four compounds, B, C, D are the less stable than the first compound. So which one is more stable now? A compound is more stable than now. Here mesomeric and here B and C conditions. C and D mesomeric, B is the inductive. So automatically B is more stable. Now identify in these two C and D. Now here minus I group. Minus I group, then next minus M is common. Then go through the inductive. Inductive decreases the stability of the carbocations. So if it is decreases the stability of the carbocations, now the minus I group, it is far away from with respect to carbocation. So distance increases more. So the stability is more in the D compound compared to C. So AB, next after the D, least one is the C compound. Now this is the stability order of this given compounds, benzyl carbocation with one NO2 group present at the given compound. Now, based on these conditions, we will discuss another example, how to identify that stability of the carbocations or the benzyl carbocations. First one, CH2 plus, here NO2 group, CH2 plus same position here, an OCH3 group, CH2 plus, here one OH group, benzyl carbocation is common, here one CH3 group, next compound E, simple CH2 plus, this one is the benzyl carbocation. Now in these all cases, which one is the most stable compound? Carbocation. So the compounds, how to identify in this, we will discuss now. Now, the first case, one NO2 group is attached to the benzene at a meta position. Okay. So these are all are the meta positions only. All are the meta positions. In this meta, if NO2 group is attached to meta means this group acts as a minus I. Next, this group is OCH3 group. OCH3 attached to the meta position, here also minus I. Here OH group is also acts as a minus I group. Inductive effect only present. If one CH3 group is present at the meta position, always plus I group, it acts as a plus I group. Now compared to that conditions, here there is no group is present in the compound E, hydrogen neutral atom only present. Then if you identify NO2 minus I, OCH3 minus I, OH minus I, in these three minus I groups always decreases the stability of the carbocation. So plus I groups always increases the stability means which one is the most stable carbocation here? D is always a more stable carbocation compared to the all. The next here all are the minus I groups compared to E. Those all are the less stable carbocations. So DE more stable. After that, here NO2 OCH3 OH. Which one effectively withdraws electrons? NO2 group withdraws effectively. After that OH. Already we discussed in the in the last videos, previous videos. NO2 group is effectively withdraws electrons. After that OH, next OCH3. So compared to that relativity of the order, OCH3 next stable compound. Next, after that C, the least one is the A. This is the stability of the benzyl carbocation with respect to given groups, either minus I or plus I groups. So whatever the compounds given in the positions, based on that we have to identify the stability of the benzyl carbocations. Next, another example. This is the one compound. Here, one CH3 group is attached. So these are the four compounds. In these four compounds, so how to identify the benzyl carbocation, stability of the or order of the compounds. Now, just identify in the first case, there is no group is present. But in this, one CH3 group is attached to the R the position. If R the position, any alkyl group is present, always a hyperconjugation only present. Hyperconjugation. Now here, hyperconjugation is dominates more than the plus sign. This is the condition here. Now, this is the para position. The para position also when more CH3 group is present. Here also hyperconjugation dominates more than the plus side. But in the fourth case, when more CH3 group is attached to the meta position, this position is meta. If a meta position, any alkyl group is present, always inductive effect is present. Now identify hyperconjugation is always donate the electron releasing group only. Hyperconjugation is electron releasing group. So electron releasing group means it increases the density compared to the inductive. Hyperconjugative system always increases the stability of the carbocations. So B and C hyperconjugation present. So the two compound stability is very higher than the D and A. And A and D, if you compare, D plus I releasing group will be present, but in A, there is no group is present. So D is more stable than the A. Now, A is the least stable benzyl carbocation. Now, coming to the BC, hyperconjugation is common. Hyperconjugation is common. Next, go through the inductive. Inductive increases the stability of the carbocation. Plus I groups increases the stability. So, which one is very near? The ortho position group in B compound. In B, it is very near. This one increases the stability effectively. So, in four compounds, given four compounds, B is more stable than C. Next, after that, D is more stable than A. So this is the stability order of benzyl carbocations. If alkyl groups which are attached to the only benzyl carbocation. So this is the stability of the given compounds. So next, another one we will discuss. Example, compound A, CH2 plus, here one CH3. Next, second compound, here CH2, CH3. Next, compound C, benzyl carbocation, here CH3 bond CH3. Next D, benzyl carbocation, here C. So these are the compounds given. So how to identify the stability of the benzyl carbocations? Now all are the para position only. Here this is the alpha carbon. According to the hyperconjugation, how many hydrogens are present here? 3 hydrogen atoms. Now the first compound has 3 alpha hydrogens. So according to the hyperconjugation, we will discuss in this case only hyperconjugation. Here also how many alpha carbon atoms? 1 alpha, 2 alpha hydrogen atoms. Next, here also hyperconjugation only present. Then coming to the next case, it is also alpha, 1 alpha hydrogen atom is present. So here also hyperconjugation only present. But now coming to the fourth case, here 0 alpha hydrogen, 1 alpha carbon is present, but 0 alpha hydrogen atoms. Now here hyperconjugation is not possible. Here only which one present? Inductive effect only present. In the above three cases, hyperconjugation, here only inductive. So compared to hyperconjugation, inductive group is less effectively release the electrons. Now like this, it increases the stability towards carbocation. Now compared to first three, the fourth one is the least stable carbocation. So how to identify the stability of the given compounds here? Now number of alpha hydrogens more will be the stability. This is the condition. So which one has more number of alpha hydrogen? First one. So A is more stable than B, B is more stable than C, C is more stable than the D. So this is the stability order of the benzyl carbocations. If alkyl groups are attached to the para position, same kind of condition if it is attached to the which position or the position also same only, it depends on the hyperconjugation relatives. The next one more example we will discuss now. A CH2 plus, here only one CH3 group. Next B, here CH2 CH3. Next third compound, benzyl carbocation. Here isopropyl group is attached to meta position with respect to carbocation. Next compound D, CH3 CH3 CH3. Tertiary butyl group is attached to the meta position. In these given four compounds, identify the stability of the carbocation. So how to identify that? If any alkyl group is which is attached to the meta position, always inductive group only present. It acts as a inductive. Now this complete CH2 CH3 group acts as a plus I. Here also this complete isopropyl group acts as a plus I group. Here this one is tertiary butyl group. It is also acts as a plus I group. Now compared to before case, here hyperconjugation present, but in this case only inductive effect only present. Now if the number of alkyl groups increases means releasing nature increases more. Here alkyl groups increases means what about the stability of the carbocation increases. So which one has more stable compound in this? D is always more stable than C. C is more stable than B. B is more stable than the A. Now this one is the stability of the benzyl carbocations. So this is the one kind of condition. Next we will discuss another conditions, different conditions. Next one, CH2 plus benzyl carbocation. Here one CH3 group is attached. Next, benzyl carbocation is common. Here one CD3 group is attached. Next, CH2 plus CT3 group is present. So these are the conditions. In these three cases, write the stability order, benzyl carbocation stability order. Here one CH3 group is attached to the para position, means hyperconjugation dominates more than the inductive. Now coming to the one CD3 group is attached to para position. Now this one also para. Here also this one is para. Here this position also para. Now this is the CT3 group. The CT3 group means again hyperconjugation more than the inductive. Here also hyperconjugation more than the inductive groups. But in these three cases, which one is more effectively release the electrons, sigma electrons? So hyperconjugation is also common. Inductive groups also same. Why here inductive effect is also same? Position, para position only. The distance also same. Then how to identify the stability? Now, now for this kind of compounds, It depends on bond dissociation energy, bond dissociation energy. So in given CH3, CD3, CT3, so which one required more bond energy? Bond energy. Bond energy case. Now I'm writing here carbon hydrogen bond, carbon deuterium bond, carbon tritium. In these three cases, which one need more energy to break that bond? So here, hydrogen mass is 1, deuterium mass 2, tritium mass 3. If the mass number increases, then the strength in between the carbon and that element isotope strength increase. Now, which one required more bond energy to break the carbon and hydrogen, carbon, deuterium, carbon, tritium? So this one is always more energy required. If the energy requirement is more means which one easily release the sigma electrons? Which one easily release? Carbon hydrogen bond only easily release the electrons. Now bond energy required more means this one easily release the sigma electrons. So releasing capacity of sigma electrons. Which one more? Carbon hydrogen is greater than carbon deuterium than carbon tritium. So now this one is more effectively release the electrons. Now based on these conditions, now which one is more stable compound? A is always more stable. A is more than the B. B is more than the C. So this is the stability of the given carbobenzyl carbocations. Just the same as like one more example we will discuss in this. Same like one more. The difference is very important. So that's why I'm explaining like this examples also. So here meta position CH3 group is present. Next the compound B. Benzyl carbocation. Here CD3 group is present at meta. Next third case CH2 plus CT3. So the difference is very important now. This now before case this one has a para position. Now here the CH3 groups presented position is meta position. This one also meta. This one also meta position. If any alkyl group related presented meta position, always inductive effect only influence. It is a plus side group. CD3 also plus side. CT3 also acts as a plus side group. So which one effectively release the electrons now? The group only directly donate the electrons. Now CT3 group release the electrons. Here CD3 release the electrons. Here CH3 group release the electrons. So compared to hyperconjugation, here group only release the electrons. If the mass number increases, that group effectively release the electrons. Now the CT3 group here effectively release the electrons than CD3. CD3 effectively release electrons than the CH3. Now which one is more stable carbocation in this? The compound C is more stable than B. B is more stable than the A. So these are the important compounds. So we discussed in this class all the different compounds, the stability of the benzyl carbocations. Okay, students, in the next video, we will discuss another type of examples. Thank you.